Okay, yeah. So the largest exponent in any polynomial is called the degree. It tells us how many solutions we can have. So
Okay.
the graph looks like this. Since it says 2, we have 2 solutions, 1 solution, or no. There'll be no real solutions because we can have imaginary solutions.
Okay.
Imaginary solutions have the letter I in it. But
Okay.
that goes into the topic when we talk about imaginary numbers.
Okay.
So
Can I see the top part?
that is top part.
Oh, okay. So it says, so is the degree the number of solutions, and whenever you see the question that says that talks about solutions, we're looking at the X intercept.
Yes.
Okay.
Yes.
Okay.
Because in chapter 1, we dealt with equations like this: 3x plus 2.
Mm-hmm.
What's the degree of this one?
There's no degree.
Yeah, if there's nothing there, it's 1.
It's one. Okay.
Yeah, so it only has 1 solution.
Okay.
And we learned in chapter 1, how do we graph this? We plot on the y-intercept and
Mm-hmm.
follow the slope up 3 over 1. So we only have 1 solution.
Okay.
And in quadratics, we have 2. And if it was an x cubed, then we'd have 3 solutions. Or we'd have 2 solutions. Or we'd have only 1 solution.
Got it.
And in the video, it tells you even degrees. If the degree is even, you can go anywhere from that number down to 0 solutions. But odd degrees, 1, 3, 5, 7, 9, has to, since in odd degrees, both ends point different directions, you have to have at least 1 solution. Because both ends point different directions, it has to cross the x-axis somewhere.
Okay.
So again, that all the explanation there and the graphs are all on the videos. So
Okay.
back to the quadratic formula. We're trying to get to the formula for the vertex.
Mm-hmm.
What the discriminant tells us, this part here, it tells us the number of solutions we're going to have. If this number is positive, that means we can take a square root of it. That means we'll have 2 solutions because that's a plus or minus in front of it.
Okay.
If what's inside the radical equals 0, that means we're only going to have 1 solution because all this stuff disappears. So we just have negative b over 2a. And if it's negative, we're going to have no real solutions, but we'll have 2 imaginary solutions.
Okay.
So far, so good?
I'm trying to understand.
Okay, well,
So
if this number inside the square root is
if
a
the number
positive
that is
number,
in square is okay, adding all that up or subtracting
right,
whatever I have to do inside. If it's a positive,
then we're
then
going to
it's
have 2 answers. We're going to have a plus and a
two
negative that
answers.
number.
Okay. So it's 2 solutions. That's what you're saying.
Right, which is what the
Okay.
picture tells us. We're going to have 2
Okay.
solutions.
Gotcha. Okay.
If the number inside here equals 0,
0.
all this stuff
Okay.
disappears. All we have
Okay.
is negative b over 2a. We only have 1 solution.
1 solution. Okay.
And if it's negative, that means it's imaginary. We'll have no solutions, no
No
real solutions.
solution.
We'll have imaginary.
Gotcha. Okay. Now I understand.
Okay? Because now, if you
Yes.
understand that, that's why this one here is important.
Okay. I got it. Yes, it makes sense. It's important because that's what's going to determine if there's 2 solutions, 1
Which,
solution, or 0.
yes.
Okay, gotcha.
And okay, on this one, on this graph here, with only one solution,
Mm-hmm.
the bottom, the only way that graph can touch the x-axis is if it's the lowest point of the graph. That is called the vertex.
Okay.
The vertex is the lowest point of the graph.
Okay.
And we get a solution if the radical, the square root equals 0. So the
Okay.
formula for a vertex is negative b over 2a. That's the x part, because it has to be a point.
Okay.
So remember, so if the square root equals 0, that's all gone. All we have left is negative b over 2a. That's our x value. Remember, a point has an x and a y value.
Uh-huh.
So once we find the x value, to find the y value, we just take this x value and put it back inside the equation.
So we're using it twice?
Yes, we have to use it once to find this one,
Once to find the X
and
and then
then
to find the
to find the
Y?
y value. Yes. So let's look how this works.
Okay.
So let's look at the vertex of this equation,
Okay.
this example.
Mhm.
We have to first figure out what a, b, and c are. What
Mhm.
is a?
Okay. So A is the 2X.
Not the x,
Is
it's
it
just a
well the
number.
2? The
Just a
2.
2, right? B is,
14.
and c.
It's 26.
Right. So once we have that, now we can look at the formula.
Okay.
We have to figure out negative b over 2a.
Okay.
That's the x value. So we have a negative. What's b?
It's 14.
Yeah, so it's negative 14,
Mm-hmm.
and a is
It's 2.
2.
Uh-huh.
So it's negative 14
Mm-hmm.
over
4.
4. Now simplify. The reason we simplify is to make it smaller, because these are pretty big numbers now.
So I get a little bit confused because I guess let's say if it was just a regular 14 of negative, I would be like, how many times does 4 go into 14?
Okay, now I'm glad you said that, because now let's look at this part here. The rule of thumb is before you ever multiply, if you have fractions, reduce first.
So you
So
was well, you would do 7 over 2?
yes, because the 2 goes into 14 7 times. So the answer is negative 7 over 2. This is a smaller number. That's what my x
Okay.
is.
But that's when I get confused because like I guess because certain things I remember, certain things I don't. Okay, I like either you will leave it like that, 7, over 2, you negative 7 over 2,
Mhm.
or sometimes like let's say it wasn't a negative and it was just 7 over 2, like I'll be like, how many times does 2 go over 7? Then that would be like a whole number, which will be
Right, because
3.
this is what's called an improper fraction, since the top number is bigger than the bottom. If we
Yes,
put it in decimals, 2 goes into 7 how many times?
3.
So that's how many left
So
over?
that's it will be 1 over 2.
1 over 2 is 1/2
It will be
is 0.5.
3.5.
Yeah, but
But in this case, we're not doing decimals.
right, because the reason being is fractions are more accurate than decimals,
Gotcha.
because 1 over 3 is much more
Mm,
accurate than 0.333333333.
Gotcha.
You can't write enough of those. So we leave them as fractions.
Okay. Okay.
Okay, so we take the equation, find the x value.
Mm-hmm. So it's okay. So that's the X value.
Yeah, for my vertex, my x value
Mhm.
is negative 7 over 2.
Okay.
Now, to find my y value, I have to take this number and put
Mm-hmm.
it inside the equation. I have to take
Okay.
-7/2, put it inside the equation. So anywhere I see an X, I put a -7/2.
Okay, so this is when it gets hard for me.
Okay, now, and this is where we're gonna show you the easy way to do this stuff.
Okay. Especially when negatives come in play, then that's also another thing on top of fractions. It's
And
the
if you watch my videos in chapter 1, I walked through that.
right away to switch it.
Yeah, because
Okay.
negatives are the part that kill people's grades.
Okay.
And I show everybody, whenever you have negative sign, always do the signs different than the numbers. Do those separately. Okay, so the first one, we have the square. What that means, -7/2 squared. What that means is I take both of these separately and square them,
Okay.
because I can't go any further in canceling those. So
Okay.
-7 times -7 is positive, because negative times negative is a positive.
And you know, if we put in the calculator, it says -49.
I'll show you why it does that.
That's crazy, but I know, like when you multiply a negative times the negative, it's a positive. But I'm just like, why
No,
does
well, I'll tell you why it does that. This number does not equal this number.
Okay.
Because when you put it in the calculator, you put it this way, I bet.
Yeah.
Because now what that
I
means,
should-
remember,
I
order of
feel like I sure
operations.
do.
Because order of operations, you have to do exponents first. So we'd have to do this first. So the negative stays out there. 7 times 7 is 49. But this one, I take the negative and put it there twice. So negative times negative is positive. 7 times 7 is 49.
Okay.
So
Got it.
that's
Okay.
so whenever you have any negative number and you square it, you have to make sure you put it in parentheses, because that negative. So
Yeah.
basically, here's the bottom line. You could, to get away from that. If you have a negative number inside parentheses raised to an even power, it's always going to be a positive.
A positive, yes.
And
Okay.
if it's odd, like if we had -2
To the
to
third
the
power.
third power, it's going to stay negative.
Negative. Gotcha. Okay. Because there's the third number.
Exactly.
Okay. Gotcha. Okay. Okay.
Okay, so
Makes
here,
okay.
so hopefully it makes a little more sense now. So far,
Yes.
so good. So we
Yes.
have
Okay.
positive 49 over 4
Mhm.
plus 14 -7/2 plus 26.
Okay.
All right, before we do multiplication, we have to reduce. Can anything reduce in this first fraction? This is
So in
in this,
this case, do you divide 49 by 2?
no,
No.
no. Right now, can 2 and 4 reduce?
Yes.
2 goes into 2 once, 2 goes into 4 twice. So that
Twice.
becomes 49/2.
Okay. Gotcha. So those canceled. 2
Those
and
can't,
2
right.
cancel. Okay.
And the next one. Now, here we have different signs. So
Okay.
positive times negative is a negative.
Uh-huh.
So that takes care, we don't have to worry about signs anymore. It's taken care of. What cancels here?
Well, the 14 and the 2.
Right. So 2 goes into 14 7 times. So 7
Okay.
times 7 is
7 times 7 is 49.
Plus 26.
26. Okay.
So this is combined like terms.
Okay.
So now here's how you do this. Since you have two different numbers and they're opposite signs, what number is bigger, 49 or 26?
26.
No, it's not. 49 is
It's
bigger than
big.
26.
Oh, okay. I'm sorry. I was looking at the negative and the
Oh,
plus.
no,
Okay.
no. It was,
Yeah.
since the signs are different, we look at the bigger number. Since 49 is bigger than 26, the answer is going to be negative.
Yes. Yes.
Now we subtract them. 49
49 minus 26. Okay.
makes it 23.
Okay, 23. Okay.
Since this is a fraction, we have another fraction there. Everything's over 1. We need to have a common denominator. We need a 2 as a denominator. So we have to multiply this one by 2 over 2.
So you have to have a common denominator?
Yes, whenever you add and subtract fractions, you have to have a common denominator.
Okay, because in this case, we're gonna be subtracting 49 and 23.
No, not 23, because we have to multiply by 2. Because
Oh, okay, okay, okay.
we have
Yes,
to get these to the same, so we have to
yes.
multiply by
Okay,
2.
so but that's the reason we're doing that is because we're subtracting, so we have to have a common denominator.
Yes.
Okay, okay, that's what I was trying to explain. Okay, okay. Gotcha. I knew that, but I just wasn't sure that we had to do this at this also like subtract. Okay, okay.
Yeah. Now, the reason we multiply top and bottom by 2, because what is 2 divided by 2 is 1, isn't it?
Yes.
So if we multiply anything by 1, we're not changing the number, we're just changing the way it looks.
Looks, yes.
So
Okay.
since we need a 2 on the bottom, we multiply 2 times 1 is get 2. 2 times 23 is 46.
Uh-huh.
Since we have the common denominator,
Denominator,
we just worry about the top,
49 minus 46. Okay.
which is
Just 3.
3 over 2.
Okay.
And that's our y value.
That
That's
is
our
so
vertex.
long. Problem, but yes, it makes sense. Like literally, like now that you're going over it, I'm like, it's it's just not. It's obviously common sense to just go based on what the equation and what you know already, and just do it. But I guess because I didn't see the lecture videos. I didn't have no clue on how to do it, but it makes sense now.
Yeah. Yeah. So again, I go through all this stuff with a little bit more in-depth detail during lectures and in the step-by-step solutions.
Yes.
Okay, so that's how you find the vertex. And that's the reason why we use this formula as a vertex.
Okay. Makes sense.
Okay, so
Perfectly
now
sense.
that's the first part. Now the second part, it says axis of symmetry. Okay, let's look at this. This is axis of symmetry. Remember, a quadratic equation, the graph looks like this. If you look at this graph, this is the graph of x squared, a quadratic equation. If you look at this side of the graph looks like this side of the graph.
Mm-hmm.
It's just we flip it across the y-axis. That's why it's symmetric. It's a mirror image.
It's a mirror. So we automatically when we like that is asking for symmetry, it's literally in mirror image.
Mm-hmm.
Okay.
Right.
It's the same. Okay.
Now what this one's asking for is the axis of. It flips around the y-axis. So in this case, the y-axis is the axis of symmetry. Now, okay, I could keep on doing examples, but let me show you the shortcut, what it really means. The axis of symmetry is the x value of the vertex. So what's the x value of the vertex? In this case, x equals 0.
Because there's only 1 point, right?
Yeah, the vertex only goes through one point, has one point. It doesn't matter where the equation is. It only has one vertex. And the line that goes through it, that's your axis of symmetry, the X value.
Okay. Gotcha.
So since our vertex in the previous part was -7/2, 3/2, our axis of symmetry,
7/2, -7/2.
yeah, and I forgot if it wants you to tell me that it's x equals -7/2, or if it just wants you to tell you just -7/2. But
Well, this one, it's in the question, it asked what was the axis of symmetry? Well, first it was the vertex, which we already have it as the -7/2 and the 3/2. And then from there, the axis of symmetry, which in this case will be the -7/2.
Mhm.
And then from there is gonna ask, it asks, does it have a maximum or a minimum value?
Okay, now maximum versus minimum. Maximum deals with the highest point. Minimum is the lowest point. Now, our equation we know it's quadratic because it has a degree 2. Now, it's the highest point. It's a maximum if A is negative. You have a lowest point, a minimum, if A is positive.
So would in this case be minimum?
Right.
Because
Because that's
more
positive. We know the
numerals.
graph opens like this. So we're going to have a lowest point, a minimum.
Okay.
And the minimum point equals the Y value of the vertex.
So in this case, now it will be the Y.
Right.
Okay.
So if the leading coefficient A, if it's positive, it opens up like this. So we have a minimum. If it's negative, if we had -2x², it would open down. So here we have a maximum.
Okay.
So all you have to do is look at the first leading term. And if it's positive or negative, then you know if you have a maximum or minimum.
Okay. Got it. So in this case, it was a little bit hard for me to actually graph it, just because whenever I try to graph it, it asks for 2 points.
Yes. Okay. Now I'm going to ask you to graph it. You know where the vertex is. The vertex is at -7/2, 3/2, which is -3.5, 1.5.
So is that when it comes to in place to help to actually graph it
Put
when
it,
you do decimal kind of?
yes, because where do you put this one? We know that if we had this, so we have 1, 2, 3, 4, -5, -4, -3, 2, 1, 2, 1, 2, 3. So we know we have to go to the left. So 1, 2, 3. So we know 3.5 is between these two. It's right there. And 1.5 is between 1 and 2. It's right there. So there's a vertex.
Right there. Okay, so that's 1 point. How would you determine how big it's gonna be?
Okay, now you can, if you want to, plug in some numbers and work it out, or use it's called the X Intercept method. With any quadratic equation, or any equation, period, the constant number is always the X-intercept.
It's always the X-intercept?
No, it's the Y-intercept. I'm sorry, that's
Oh, the
Y-intercept.
Okay, the Y-intercept. Okay.
Yeah, because we're looking for the Y-intercept up here, not the
Okay.
X-intercept. This equation, if there's the vertex at negative 3.5, 1.5, and it opens up because it's positive, we have no X-intercepts. All we know that the graph is going to cross through the Y-axis at 26.
Okay.
But that's pretty far up there.
Yes.
So what you could do is take -4 and -3 and plug those into the equation
Oh, okay, okay.
and work it out, and it should give you some solid numbers.
Gotcha. Okay. Makes sense.
Yeah, because there's no decimals or fractions anywhere, so it'll give you, and then you just plug them in there. Now symmetry, you don't, since you're looking at this point here, it's halfway between 4 and 3. Once you find this number at -4, let's say it equals 4, I automatically know this one's going to equal 4.
Okay.
Because if it's symmetric, then if I go from the axis of symmetry, if I go 1.5 spaces to the left and I go 1.5 spaces right, they should give me the same answers because
Okay.
of symmetry.
So in this case, because we just worked this, would it be considered the same way? Would it be considered the same problem using this one?
The one you just have on your screen?
Yes, just because
Yeah, we'd solve it the same way.
Okay.
So actually, let me show you using the basic y equals x squared. The graph of this one is like that. When x is 0, 0 squared is 0. So there's our vertex.
Okay.
If I go 1 to the left, -1 squared is 1. If I go one space to the right, 1 squared is 1. If I go 2 spaces to the left, so -2 squared is +4. If I go 2 spaces to the right, it's going to be +4. So that's why it's symmetric. If I figure out where the axis of symmetry is, and if I go 2 spaces to the left, I know the answer is going to be the same if I go 2 spaces to the right.
Okay.
Because the axis of symmetry is there. So it doesn't matter where your axis of symmetry is. Let's say our axis of symmetry is there. This is at 4. If I go 2 spaces to the left, I know it's going to be the same answer as if I go 2 spaces to the right.
Okay.
Does that make sense?
Yes.
Because again, the axis of symmetry, if I fold this thing, it's going to have the same answers.
Yes. I have the same Y.
Yes, correct. Because yeah, it's the same distance away from the axis of symmetry, the x values.
Okay. So the question that I was just asking, which is another question on chapter 8, I guess on the sample, it's just worded out different.
On chapter 8?
I mean, on question 8, chapter 3,
Okay.
section 3.
Let
I
me
guess
see.
how they input it, it's a little bit different.
Okay, chapter 3, section 3, number 8. Six, 7, 8. Yeah, okay, so vertex. Okay, yeah, that's the same type, isn't it?
It's the same thing.
Yeah.
Okay. So it's just worded out different. I mean,
Okay.
the sample.
And now we have X1 should find the range and the interval where it's increasing or decreasing.
Okay.
All right, let's look at ours we just did.
Mhm.
I'm sorry. Can you? I'm sorry. That was rude of me. I should have done that. So now you see we're looking at the same equation here.
Okay.
So this was asking for the range and the interval of increasing and decreasing.
Mhm. Let me close it.
Okay, so let's go back to our previous example.
Mhm.
2x squared plus 14x plus 26. We know the vertex is at -7/2,
Mhm.
3/2. One, two, three, four. So we know that's our vertex. It's positive, so it opens up. So domain and range. What's the difference?
That one does the handles the X and the other one is the Y.
Which one's which?
The domain is X and the range is Y.
Very good. So for quadratic equations, the domain is always what this says is from negative infinity to positive infinity. It's all real numbers because it keeps on going forever and ever, both directions.
Okay.
The Y values, because it opens up, our smallest number we have is at 1.5 or 3/2. So it goes from 3/2 up. Oh, you have to go pick up your son, don't you?
Yeah, but I'm listening.
Okay, so
I'm just backing up. It's down the street.
okay, so from the range you look at, since it's opening up, we start at 3/2 and it goes up to where? Infinity.
Uh-huh.
And since we can use 3/2, we put a bracket there. And you can never reach infinity or negative infinity, so you put parenthesis there. So brackets means you can include the answer. Parentheses means you cannot include that number in the answer. You could ever get to it. So the range is that. Or you can say that y is greater than equal to 3/2. All depends on how the question asks you to put the answer. If it wants intervals, you do it this way. If it wants a range, then put it that way.
Okay. So it's either a close one, what's it called? A bracket? What's it? A bracket?
A bracket.
Is it a bracket? Uh-huh. On the
Yeah.
left one, and the infinity, it's a parentheses.
Right. If you notice on the domain, I put parenthesis because you can never reach infinity.
Yes. Okay. And
So,
that's what it is.
or
Okay,
you
if
could
you-
put that answer. However the question wants it.
Okay. That makes sense now.
Okay.
I guess it threw me off a little when it said
Oh, yeah. Because all of a sudden just throw it in there. So now it also asks you, where is it increasing? Where is it decreasing? When it says increasing, that means it's going up.
Okay.
Decreasing, it's going down. So at the vertex, it doesn't do anything. So at -7/2, that's where it stops doing anything.
Okay.
So everything from -infinity all the way to -7/2, the graph is going down.
Okay.
So decreasing, it's from -infinity to -7/2. And they're both parentheses. Because at -7/2, it doesn't do anything. So it's neither increasing or decreasing. So that's why it's a parenthesis. You're not using it. And
Okay.
where does it goes up? It goes up from -7/2 all the way to infinity. To positive infinity. That's where it's increasing. So now if we had a negative graph, let's say we had a graph that looks like this, and the vertex was at 4, the increasing and decreasing would change. Because everything to the left of 4, it's going up. So that's where it's increasing. From -infinity to +4, it's going up. Then from 4 to infinity, it's going down.
Okay.
So, and whenever you do increase decreasing, you never use brackets. It's always parentheses.
Parentheses. Okay.
Okay, so that takes care of that stuff.
Yes.
Okay, I tell you what, go ahead and pick up your son and look at your homeworks. And if you want to, then we can meet again tonight or tomorrow
Sounds
or
good.
both.
I'm gonna try to see what I can do. When I've come across other problems, we'll go over it. I'll
Excellent.
send you a message just to make sure you're available. Okay.
Yes, that'll work perfect.
Okay. Sounds good. Thank you, Professor.
You are very welcome. Drive safe.
Thank you.
Bye-bye.
Bye bye.